Light is a form of energy that allows us to see the world around us. It exhibits both wave-like and particle-like properties, a concept known as the dual nature of light. The wave nature of light is evident in phenomena like interference and diffraction, while the particle nature is illustrated in the photoelectric effect. Both characteristics are essential for a comprehensive understanding of light. This lecture will explore both aspects in detail, providing examples and applications to solidify your understanding. The wave nature of light can be described using three primary characteristics: wavelength, frequency, and speed. Wavelength is the distance between successive crests of a wave, typically measured in meters. Frequency is the number of waves passing a point per second, measured in hertz. The speed of light in a vacuum is a constant 3 × 10 to the power of 8 meters per second. These properties are interconnected through the equation C equals lambda times F. Understanding the wave nature is essential for explaining phenomena such as diffraction and interference. The particle nature of light is best explained by the photoelectric effect, where light ejects electrons from a material. This effect was explained by Albert Einstein, who proposed that light consists of photons, each carrying a quantum of energy. The energy of a photon is related to its frequency by the equation E equals h times F. The photoelectric effect has significant applications, including in solar cells, which convert light into electrical energy. For NEET students, understanding this effect is crucial as it highlights the quantum nature of light. Reflection is the process where light bounces off a surface. The laws of reflection state that the angle of incidence is equal to the angle of reflection. This principle applies to all types of mirrors, including plane, concave, and convex mirrors. Understanding reflection is essential for applications like designing optical instruments and solving NEET problems related to image formation. Practice with various mirror equations and ray diagrams will enhance your problem-solving skills for the exam. Refraction is the bending of light as it passes from one medium to another with a different density. Snell's law governs this phenomenon and is expressed as n1 sin theta 1 equals n2 sin theta 2. Total internal reflection occurs when light travels from a denser to a rarer medium, and the angle of incidence exceeds the critical angle. This principle is used in fiber optics and other technologies. Mastering refraction and Snell's law is crucial for NEET, as many questions involve calculating angles and understanding the behavior of light in different media. Dispersion occurs when light splits into its constituent colors while passing through a prism. This happens because different colors of light have different wavelengths and refract at slightly different angles. Isaac Newton demonstrated this by passing white light through a prism, producing a spectrum of colors. Natural phenomena like rainbows are also a result of dispersion. Understanding dispersion helps explain why we see different colors and how light behaves in various conditions. For NEET students, comprehending dispersion is vital as it links to questions about the nature of light and color formation. Interference is a phenomenon where two waves superpose to form a resultant wave of greater lower or the same amplitude. Thomas Young's double slit experiment is a classic demonstration of this, where light passing through two slits creates an interference pattern of bright and dark fringes on a screen. This experiment provided evidence of the wave nature of light. Understanding interference is crucial for NEET as it involves critical thinking and application of wave principles. Mastering this experiment and its equations will help tackle related questions effectively. Diffraction is the bending of light around obstacles and the spreading of light waves when they pass through small openings. This phenomenon is more pronounced when the size of the obstacle or opening is comparable to the wavelength of light. Diffraction patterns are characterized by a central bright fringe surrounded by alternating dark and bright fringes. A common example is the diffraction grating, an optical component with a series of closely spaced lines that diffract light into several beams. For NEET students, understanding diffraction is essential for explaining wave behavior and solving problems related to wave optics. Practice with slit experiments and diffraction gratings will enhance your analytical skills. Polarization refers to the orientation of light waves in a particular direction. Unpolarized light has waves vibrating in multiple planes, whereas polarized light vibrates in a single plane. Polarization can occur through reflection, refraction, or by passing light through a polarizing filter. Polaroids are materials that filter light waves, allowing only those vibrating in a specific direction to pass through. They are used in sunglasses to reduce glare, in photography to enhance contrast, and in various scientific instruments. Understanding polarization is vital for NEET, as it involves concepts of wave behavior and practical applications. Several key laws and equations are crucial for mastering light phenomena and excelling in NEET Physics. These include the wave equation, C equals lambda F, the energy of photon, E equals hf, the laws of reflection, angle of incidence equals angle of reflection, Snell's law, n1 sin theta 1 equals n2 sin theta 2, the lens or mirror, equation, 1 over f equals 1 over v plus 1 over u, magnification, m equals minus v over u for mirrors and m equals v over u for lenses. Young's double slit equation, delta x equals lambda d over d. Mastering these laws and their applications will greatly enhance your problem-solving abilities in NEET. Optical instruments like microscopes, telescopes, and cameras rely on principles of light to function. Microscopes use lenses to magnify small objects, while telescopes gather light from distant stars. Cameras capture light to create images, using lenses to focus light onto a sensor. Everyday applications of light include fiber optics for high-speed internet, lasers in medical procedures, and LEDs for lighting. Understanding these applications demonstrates the practical significance of light phenomena and their impact on technology and daily life. For NEET, knowing how these instruments work and their underlying principles is crucial for both theoretical and practical questions. In summary, light exhibits both wave-like and particle-like properties, which are fundamental to understanding its behavior and applications. The wave nature is characterized by wavelength, frequency, and speed, while the particle nature is highlighted by the photoelectric effect. Key phenomena like reflection, refraction, dispersion, interference, diffraction, and polarization are crucial for explaining how light interacts with matter. Understanding important laws and equations, such as the wave equation and Snell's law, is vital for solving NEET problems. Optical instruments and everyday applications of light demonstrate the practical significance of these concepts. Mastering these topics will not only help in NEET, but also provide a strong foundation for further studies in physics and related fields. To conclude, here are some common questions and practice problems to test your understanding. Question: what is the dual nature of light? Answer: light exhibits both wave-like and particle-like properties. Question: how does the photoelectric effect support the particle nature of light? Answer: it shows that light ejects electrons from a material as discrete packets of energy called photons. Practice. Problem 1. Calculate the wavelength of light with a frequency of 5 times 10 to the power of 14 Hz. Solution. Use the wave equation C equals lambda F. Practice problem 2. Using Snell's law, find the angle of refraction if light enters water with an index of refraction of 1.33 from air with an index of refraction of 1 at an angle of 30 degrees. Solution apply. Snell's law n1 sin theta 1 equals n2 sin theta 2. Regular practice with these problems will enhance your analytical skills and prepare you effectively for the NEET exam.